Welcome everybody to the NGI Technical Podcast. The NGI Technical Podcast is a medium where we talk about technical topics related to geotechnics from experts and for experts. This means that we are talking about things in a bit more detail, but it definitely should be understandable and interesting for geotechnical engineers, engineering geologists, and other people that are interested in the field worldwide. My name is Georg Erharter, and I'm the host for today's session. Today we are going to talk about onshore geotechnical engineering in Scandinavia. And for that, we have two guests in the studio. So on the one hand, we have Tone Smaavik, who is a section head here at NGI. Tone is originally coming from Norway. She has done her master's in civil engineering at the University of Bristol. She has then been working offshore for the former company GEMS, doing offshore geotechnical site investigation and design. And since 2012, she's at NGI, where she has had different positions, but right now she's the section head or the department head for onshore geotechnics. On the other hand, then we have Mr. Robert Thurner. Robert Thurner is originally from Graz in Austria, like I am. I'm also from Austria. And Robert has been doing his PhD at the Graz University of Technology at the Institute of Soil Mechanics, Foundation Engineering and Computational Geotechnics, where in the year 2000 already he has finished it under the supervision of Professor Helmut Schweiger, and the topic was, I read it in German, Probabilistische Untersuchungen in der Geotechnik mittels deterministischer finite Elemente Methode. So it was about probabilistic analysis in geotechnics with finite element modeling. Having finished his PhD, Robert then started working at Keller, one of the largest construction companies in the world that is also dealing with geotechnical engineering and ground construction, basically. He started there in Austria in the year 2001 and built up the R&D department for Keller in Southeast Europe. And then he was working for Keller all over Europe in different countries as regional manager. From 2014 to 2018, he then moved with Keller to the Middle East, where he was the technical director. Then in 2018, he moved to Sweden to lead Keller in Scandinavia, where he now is the head of the technical office and special projects at Keller Grundläggning in Scandinavia. One thing to mention for the episode is that Robert is right now organizing a special issue in the journal Geomechanics in Tunneling that is focusing on Scandinavian geotechnics. So we will put the link in the show notes. Feel free to check it out. It will be published in the April issue of the journal. You can find further information and contact details in the show notes, so please direct any questions, comments, and concerns to us, to the email address that you can find there. And with that, let's go. Welcome, Robert and Tone, to the NGI Technical Podcast. I want to start right into the technical discussions. And I want to start with a little anecdote. So when I started at NGI, I made and for me, a bit of a peculiar observation that I found that in Scandinavia, there is a bit of a different understanding of what geotechnical engineering actually is. And that comes from the background that in Central Europe, I would say engineering geology is more about ground characterization and ground modeling and these kinds of things. Whereas in geotechnical engineering, it's more about the design of structures, but both in soil and in rock. And here, I remember I talked with my boss. I asked him, what is the difference, or where is like the border between geotechnical engineering and engineering geology? And he responded, it's difficult and sometimes overlapping. And then you have these weathered rocks, and then sometimes you have these very hard soils. And I realized it's more of a question of soil versus rock and not so much about ground characterization versus design. Does this also correspond to what you observed, or what do you think is the definition of geotechnical engineering here?
I think your statement is quite right. In the Central European perspective, it's clearly separating the materials, soil and rock. And it's due to the difference in culture, it's obviously different here in the north.
Yeah, no, I agree. And I think a lot of it comes from some of the Norwegian universities, who've also trained people. So our geotechnical engineers come from civil engineering in one department, and then the engineering geologists come from a different department of the university. So they become very separate, and they can choose to take subjects from the different departments, but it's not necessarily so easy. So they become very sort of separate directions, and then we meet again in our working lives, but with slightly different kind of technical terms and slightly different approaches, and then we have to find a way to work together.
I also heard once that it's related to some like a quarrel between professors in the past, in the 60s, 70s or something, that persists until today, but that might have been speculations. I don't know.
But what you clearly see is the difference if at the university level, the guys or the professors or the involved persons are really start to cooperate. Because this is a significant difference. We have it seen, for example, in this geotechnical group in Graz. When they started to work together, it's much more beneficial for both parties, or all three parties, the rock mechanics, geologists, and soil mechanic guys, because then they have a chance to understand a bit better where the other's coming from. And it's much more fun and much more beneficial also what is the outcome of projects, research, and so on.
Yeah.
That's so obvious.
Absolutely. And I think it's also a big challenge in practical life, but also it starts in studies, is that you get people to communicate with each other efficiently and that they speak a common language. So, I mean, these barriers in general, it's a bit questionable if they are helpful, I guess. But aside from the university background, do you think, are there other reasons why there is this more of a soil versus rock kind of perception here than in other parts of the world?
I think typically in Norway we have very hard rocks, so our tunneling is it's through very hard rocks where you can use the rock face as a structure, and you can design more as you go. You design your reinforcement as you go, and then we have very soft soils. So they become kind of like two separate worlds. But like you said, we do of course have weathered rocks, we have moraines, we have all these things in between that we do have to deal with. But I think the extremes are very far apart, and that's kind of what we've used to define our disciplines.
Yeah, that makes sense, of course. From an international perspective, what do you think are specialities of the Norwegian geology that we have to deal with in construction?
So I'm from a soil background.
Same here.
Yeah. So we do have very soft soils. That can be troublesome. We have very soft soils, but we also have what we call sensitive soils or quick clay, which is typical for Scandinavia.
I think this makes the difference, the sensitivity, not the softness, I would say, per se. Because soft soil you find also in other areas also. I don't know, I have worked a lot in Egypt, for example, and so on. There you find even till 50-meter depth, a similar type of softness, to call it in the simple way.
Southeast Asia as well, but the sensitivity is something that we see in Scandinavia, Russia, Canada, Alaska. So the quick clays that we have, they come because of the ice age that was about 20,000 years ago. So at that time, we had maybe 2,000 meters of ice on top of the land that we have today. And when this ice melted, the weight that came off caused the land to rise. And that means that soils and clays that were below sea level are now above sea level. So we find that material now up to like 200 meters above the sea level that we have today. The salt in the sea helped stabilize the clay and the clay molecules. And then over time, as this clay was now above sea level, slowly, the salt in the clay leached out. And that causes a more like unstable structure. And that's the quick clay that we see. So now it's, if the clay is now overloaded, it collapses very quickly. Yeah. It's a very sudden and kind of catastrophic failure.
Or if you disturb it.
So any kind of remolding, it will go pretty much liquid.
Is this comparable to what people understand as liquefaction, or how would you say, what is sensitivity of soil that we have to deal with here?
We define like a quick clay, we would say, has a remolded shear strength of less than 0.5 kPa. And then we have some sensitive soils would be less than 2 kPa. So very, very low strengths in a remolded form.
Mm-hmm. And the danger is, I think, in the practical application that you have first a sort of stable slope. And when you touch it in the wrong way, or when you, whatever vibration bring in, causing this liquefaction, you end up with a sort of fluidized slope. And then everything is flowing around or below the rig or below the equipment. And that's the danger, that it can quite quickly change the sort of strengths, or in reality, how it appears in nature.
Yeah.
Which leads also to the fact that you have to think about, for example, how you have to pre-treat the soil before you can excavate it at all, which is for sure a difference than in many other areas.
Yeah, for sure. How frequent is this phenomenon, or how often do we have to deal with this?
When you're in the area, you have to learn to read the red card, I would call it. Mm-hmm. So you have simple overviews, maps showing the areas where you can expect this, plus you have the soil investigation. But there are clearly sort of Swedish, Norwegian, Finnish maps where you can see in which areas they are. And they are along some coastlines, some riverbeds, and those things. So as Tony described where it comes from, then also you know roughly where you can expect it.
Okay. Mm. And you said up to a height of about 200 meters above sea level?
Yeah.
Depending on how far the land has risen from the sea?
Yeah, so we also have maps showing this for different areas. So we call it like the marine boundary. And that's kind of like your trigger for knowing that you have to maybe do additional site investigations, check existing maps and define it. Because it can be quite local as well. Because you can get sort of pockets of quick clay within areas that are otherwise more stable.
And I think the interesting part is that, as in other areas, you got used here in this area to work with it, to live with it, and to handle it and design it properly. And I think there is nothing more complicated than this. It's just more, tricky what is the outcome if you do it wrong, because you have fluidized soil. But so you have a risk map, you have clear measures how you have to deal with it and how you have to design it.
Yeah.
Yeah, and I think that's really important, because undisturbed quick clay is not a problem at all. Quick clay in itself is not dangerous to anyone. It's if you get into a state where it's remolded, then you've got some issues. But if you treat it properly and you're aware of these things and you design for it, then it's not really a problem.
And in reality, there are some methods which are even working better if you have quick clay, because it's easier to disturb, to mix something, and then you have afterwards a stabilized ground.
Okay. Yeah, very, very challenging and fascinating material for sure. Were there any bigger incidents in the last years related to this material?
For sure. Several of them. I would say in the frequency of some years, you always have one or the other landslide. Recently at the E6 in the Swedish northern part of towards Oslo, from Gothenburg north towards Oslo. You have the E6 landslide, which was somehow caused by obviously not understanding the full situation in a geotechnical or geological sense. And this was repaired in, I think, 8 months or so. Then there were some landslides before, and it's also there interesting to see how different authorities, different experts handling such a case. Sometimes you go in the day after, investigate. Some authorities are requesting that you need some months before you go in. So it's also there, obviously, there are different views how you can handle such stuff.
Okay. But I mean, given that this is such a widespread phenomenon, I think also for the authorities, it has to be very challenging to deal with, right? Because it's you cannot just avoid it in principle, because it's everywhere and there are structures already on the quick clay.
We definitely see municipalities where they know they have lots of quick clay. They have worked to increase their awareness and their readiness and everything around it. And they have readiness plans in case of events. But it also requires quite a lot of them to evaluate every single building application they get, right? Because we typically work in big projects. We work with roads and railways and hospitals and that sort of thing. But in some areas, it's also an issue that someone, just wants to extend their house or dig a bit or move some ground. So we have colleagues at NGI who've done some research into quick clay slides in the past say 15 years. And we see an increase in quick clay slides, but most of them are actually triggered by construction activities.
Mm-hmm.
So one thing, like one trigger for a slide could be just erosion, so natural erosion. But most of the slides that we see have some kind of more mechanical cause, someone digging, someone filling in the wrong place. And then that can trigger something really, really big.
Yeah. Okay. Interesting. What do you think about dealing with quick clay from a authority perspective?
You see also the difference in the different nationalities.
Mm-hmm.
So depending on which side of the border, sometimes the handling is different as the design is different. Maybe we come later to this, but that's a clear point what you see. And on the other hand, I don't know, also in the Alpine area in Austria, we know that there's a risk of landslide sometimes. And we know that we cannot prevent everything.
Yeah.
So it's simply a question to the society. What is the probability you are going to accept?
Yeah.
And that's how it's to be seen here as well. And I think it's like the standard foundation works we see also in the inner city or in general in Europe and for sure also abroad, that due to the limited space, we have to use different soil areas or areas where the soil is bad, in a sense of more effort is needed to handle the soil conditions. And that's the same here. We are doing more constructions where we previously would not have built anything. So therefore there's more risk.
Yeah, for sure.
Yeah, absolutely. And it's, we're building and, it's often like in quite attractive places, close to water. And it's the sort of trickiest of plots that are left for us to build in. We're not really in a position to avoid building on quick clay in Norway. We have a lot of mountains as well, but we don't all want to live on the top of a mountain. So
true.
So we find ways to build on and in the quick clay that are safe.
What do we then do from a design perspective to deal with this material?
Well, we luckily have ways to reinforce the clay and to increase its strength and stability. So what Robert mentioned already was that the good thing about quick clay is that it becomes very liquid and it allows us to mix in binders and create a very homogeneous material that we can design with. So we use it, then we can create structural elements in the ground by using different binders and achieving different strength and stiffness. And sometimes we also add a little bit of binder just to be able to excavate the soil. So we do have to do something, even with the soil that is not really part of our project that we're not going to use for anything, but we're not able to excavate and transport a liquid material.
Yeah.
So we need to increase the strength just a tiny bit to be able to actually get it off our building sites.
Okay.
Or even to allow the real construction works. For example, a very sort of one standard method to improve the soil around diaphragm walls before you do the grab system, because otherwise you have problems, or you could have problems with your trench stability. So therefore you pre-stabilize the soil with the, for example, dry deep soil mixing method or mass mixing, and then you excavate because you can open bigger trenches. And the other thing is, next to supporting the excavation, you also apply basically the same method, maybe the same or a bit different pattern to minimize deformation, because it also helps for minimizing deformation of excavation bits.
Okay.
Because then you have a bit of a better material inside and you have the allowable deformation for the surrounding structures.
Yeah. But I mean, it also must be challenging to deal with this from a construction logistics point of view, because since it's so sensitive, there must be a certain order that you have to do things, and you cannot just start everything at the same time and work all over the project. For a contractor, how do you approach this projects that are then dealing with this problem?
I think the advantage, as mentioned before, you're used to live with it, and therefore certain things are already clear in the design or in the project preparation phase. As long as everything is flat, it's much easier because there is just liquefaction and it's more the certainty of the working platform and those things which are count. counting. And on the other hand, if you work on slope stabilization project where you have quickly, then it gets logically much more challenging regarding the, for example, working sequence, additional measures like counter embankments, vertical drains installation, and those things, what you can do to make sure that you have still under the execution phase required safety measure against slope stability.
A bit of a topic change. I mean, many of these measures, they require a lot of intervention with the ground. They require improvements and reinforcement and these kinds of things. How is this in terms of sustainability? Because sustainability is a big topic today, of course, or I mean, kind of, we just switched from the Green Deal to the Clean Deal, but still we are talking about sustainable practices a lot in our industry. These are pretty heavy methods in some parts. So does this go along with an overall trend towards sustainability and sustainable goals? Or do we just ignore this?
Both.
Okay.
I think it's unfortunately the topic or a point that we do both. On one hand, it's a big topic about sustainability, which is followed by trying to find sustainable solutions, sustainable materials, and those things. On the other hand, the climate is not everywhere there that we are also having a chance to apply sustainable thinking and maybe alternative design, alternative methods, and those things. I think there is for sure some room for improvement also in the Scandinavian area, even though I have to say in Central Europe or in other areas, even the base thinking for this sustainability in the building industry is always covered by the price counts.
Yeah. With climate, in this case, you mean more like the working culture or the actual climate?
Working culture, defining rules.
Yeah. How do you see this, Thorne?
I think we approach it from different directions, really. So one thing is we always aim to reduce, the amount of soil reinforcement that we need. And if we're looking at slope stability, there are other measures that we can do as well that we would consider first. But then when we do need soil reinforcement, which we often do, there's lots of ongoing research, and I think in every single project we work to optimize and to minimize the amount of binder that we need, and change it for the local conditions. So we try to always have a test site and see what do we actually achieve in terms of strength and stiffness in the field, what do we need for our design. But I feel like the industry is pushing that forward faster than the regulations, because we know that, cement and steel, all of these things are huge contributing factors to the overall CO2 budgets of our projects. Often the groundworks aren't included in those budgets, but we know working with it that it's a huge part of it. And if we want to make a difference, if we can cut the amount of cement that we put into the ground, then that's beneficial to our project. So I find every project I've been in, we optimize and we do local testing, and we build up a confidence for that project in what amount of binder do we need for our particular purpose.
Thanks, Thorne, for clarifying this, because that's a bit what I was targeting, that on site, on the, I would call it now, engineering level, it's a lot of thoughts what we can do and what we are doing already. But on the other hand, as is mentioned with the regulations we have in, again, different areas, Finland, Sweden, Norway, and wherever, where these methods are standard, we are bound to use certain minimum quantities. We are bound for certain maximum values in the design, and those things which are not up to the standard. For example, for the material we are using today, it's maybe right for what has been used 20, 30 years back, but not for today. And we could do better if we would have been allowed to do better, in the sense of the design really utilizing the entire strengths we have in the material not after 28 days or 14 days, maybe after 56 or even more days. Those things are a bit limited, which could significantly reduce further the needed measures we do, and therefore also the climate impact.
But there is ongoing work now to update. So we have a Norwegian guideline by the Norwegian Geotechnical Society. The current version is about 15 years old maybe, on the guideline for soil reinforcement. But they're working now on updating it and including various research projects on the topic, and I think also experiences that we have from our different projects that weren't necessarily research projects in their own, but they are experiences from different construction projects. And when you put all that together, we see that we work in a different way and we can achieve very good results with much less binder than what's typically been said in the standards. And that's something that I think we all want. We don't want to over-design.
For sure. But does that mean that in the past we just used too much in general? Or, I mean, because also I think engineers always try to optimize their design with respect to some goal. And in the past it was at least very openly about money. And now it's about resource consumption. But this also this also is reflected in the numbers. So were we just wasteful then? Or what do you think about
potentially, maybe not in every project, but what we see is that the local variations are very big. So the same amount of binder applied in two different locations can give you very different results. So we've also had examples where we used the standard amount of binder in our soil, and if it was very, very quick, we got very, very good reactions, and we ended up with soils that were too hard, so they couldn't be excavated in the end because they would, sort of 800 kPa, which is way above what was needed. So it's actually caused a bit of a problem instead that then needs to be handled on site.
And I think what you see is also the difference in some ideas how to design, for example, this mass mixing or dry dipster mixing. Recently we came up with certain areas, projects where even in the design, a very high kg was foreseen because they would like to reach a high strength value. And at the end, what you get is a brittle product. So, which is also a bit against what originally was the idea of this lime or lime cement columns. And there you see that the product development was faster than the regulation on one hand, and especially which material was requested. And also that the testing was not able to provide what should be needed for a proper design. So you have to be on the safe side because you cannot even test the product properly till a certain strength value. So it's a bit of a problem. What luckily now is the focus on sustainability is now again on the plate of many projects, many researchers in Norway, in Sweden, and maybe also in other areas.
Okay, very interesting. You mentioned many standards and regulations now already, and now we are starting to introduce the second generation of the Eurocode 7, which is a big deal for geotechnics at least in Europe, but also abroad. And this new Eurocode, some people are afraid that it will give an incentive towards more conservative design, and that people are afraid that this will make it even more conservative, even more resource extensive, and so on. What do you think about this?
I think both of us are not really experts in the Eurocode standards. On the other hand, I had recently a discussion with two of the guys who are involved, or the experts involved in the implementation in Sweden, and it unfortunately underlines what you said, that it seems to be going towards a conservative design, and some comparison calculations are obviously negative in this respect. But this is only one topic for me. What is bothering me much more is that I'm now quite old already, sort of in more than 30 years in practice. And when I did my master thesis, I had already this discussion about comparison calculation and how complicated we get with our design. And when I see how tricky the application of Eurocode and all the standards, if you really would like to apply it, plus all national documents, is getting, this is not helping us. I don't think it's the proper way to go. If on the same time, we also would like to attract young guys for what we're doing, and that it's possible to be followed. And especially, I think what is still needed, it's geotechnical or geological engineering, and you need feeling. And if it's getting too complicated, you have no chance to develop a proper feeling in a reasonable time, which is quite sad for me because it's also minimizing the fun.
absolutely. Yeah. But I mean, speaking about the past, already in your PhD, you were doing probabilistic finite element modeling for geotechnical engineering 25 years ago. And now in the second generation of the Eurocode, this is building heavily on probabilistic methods. Why is this, or what do you think about this time lag?
I think it's still here that we discuss about probabilistic. It's the same that the question is how far we would like to go, what is the database, what we really can apply, and at the end, it boils down very quickly to safety factors, partial safety factors, global safety factors, whatever you do. I think it's at the end still the common sense which has to be applied. And this was one of the major benefits I had throughout my career, that the understanding of uncertainties is a different one if you start to think about probabilistic, but still keep it on a reasonable level. Because we don't have the database, because that's, for me, physically speaking here or practically speaking here in the Nordics, having even this tricky soil conditions, the level of the soil investigations and especially the quality what you finally have is not on this level about the sensitivity of the soil, for example. Sometimes you really wonder that in very often you see in the report the subject of further detailed investigation, which in reality never happens.
Okay.
So you see that if I come back to your question about the probability, you can do a lot, but then you would need the database.
Yeah. But I mean, if we would have more ground investigations, would there be then a benefit of applying these probabilistic methods?
It is already a benefit if you apply probabilistic methods. It's just a question how far you go. And you can do simple point estimate methods, or you can do Monte Carlo, or whatever you do. It's always a question where you end and what you do with the outcome.
Yeah.
Because if you do stability design, you need the tail at the end. And for having a proper accuracy on the tail at the end of the distribution, you need a real good input quality. And this you rarely have.
Yeah, absolutely. This is a challenge, yeah. Talking about recruitment and getting young people into the industry, how is this for a contractor these days in Scandinavia? I hear that in other parts of Europe we are struggling a lot with getting new people into our business. How is it here?
It's the same.
Yeah.
In reality, it's not easy to attract, and that's why I mentioned before the fun, because that's the key factor if you would like to attract. And the other thing what I really like in the Nordics, Scandinavian area, is that you have a chance to work more normal, as I call it normally. So it's a basic fair setup to deal with each other in the construction industry, which is quite a base factor also for having fun. Because if you're able to work fair together, you have also a chance to be open. You can much more develop. You can also take easier, okay, sorry guys, I have been totally wrong. This is a mistake from our side. We have to handle this. If you do this in the wrong environment, you're always fully distracted directly into commercial, legal discussions and so on. And on the other hand, it's giving a much better environment to develop new stuff.
Yeah.
I see that in Norway as well. That we have quite a sort of egalitarian culture in our companies, in our schools, everywhere. You know, there's everyone's kind of entitled to their opinion. We try and include people in meetings and listen to each other and have a good sort of collaboration environment, which I think is really important for the fun, for learning. And when we learn, we also make mistakes, and figuring those things out together is really, really important to create a positive development and to bring the industry forwards as well, I think.
Yeah, for sure. That's important. But especially from the contractor's perspective, I hear quite often actually the argument that the young people, they are so work-life balance focused, and then you are having these projects where you have to send them on site for 10 days, 14 days, whatever. They don't want to do that. Nobody wants to get into these things anymore, and so on and so forth. it's nice to have fun, but the working conditions in our field, they are different than, let's say, the average consultant in other sectors. How do we deal with that?
We have to adjust. It's so simple. If we are not able to adjust, we will disappear. And this we see already with our models for young engineers, especially if they are on site. We have to have rotations and those things, otherwise it's not working. And it's not easy if you're grown up and coming from a different mindset. On the other hand, if it's a sort of closed circle, that with this you also have a chance to get certain projects managed and attract people that you can do the projects, and on the other hand you also have a chance to get paid for it, then it's working. It's always the problem if in this type of situation or culture a lot of different approaches are seen from different companies, and they have a chance to do it for a short time, because then you have no chance to develop something sustainable for the young guys in your own company.
Yeah.
I think we talked about sustainability from a CO2 point of view, but I think this type of sustainability is also crucial for the industry. And if you see that you go into a profession that is also or has to be a lifestyle, then that can be a huge challenge, and I don't see many young people thinking, sacrificing sports or having a family because they're going to be working nights in a tunnel all their lives. I can see that's not a very attractive kind of selling point. So I agree with Robert, finding new ways of working that doesn't kind of make people sacrifice like maybe people have in the past, because we still need to build things and we still need to manage our sites in an efficient and safe way, but we need to look after the people that do it in a better way as well.
I mean, in principle, I fully agree, of course, but also it's a bit of a question of competitiveness, isn't it? Because then if you are the contractor that offers very let's say work-life balanced, focused work habits, then I would see some people being afraid that you would not be able to compete with another contractor who is not sharing these values and goals.
It's fact. There is no way to discuss this. It's the same in the consulting business. It's the same in the construction business. That's what I tried to say before. If you have a sort of closed market, or at least a defined culture, what you have to follow, and also the clients demanding this, then you have a chance to organize it on a long run. As soon as you allow that, I don't know, the typical situation is that foreign companies are coming in, fighting hard for a project, and then getting in a lot of different guys who are working on different conditions because they're only here for half a year, and it's fine if they earn in this half year a bit more money and to sacrifice time and whatever. Then you have no chance to compete against certain prices. It's so simple. So if you would like to maintain this as society here in the north, you also have to make sure that this is kept sort of on the real daily agenda, that those things have a certain value and are remaining in the companies.
Yeah. How this also requires, however, also certain clients that are open for this and that are not just going for the cheapest offer. How do you see that this is in the north when you compare it with the rest of where you've been working?
It's mixed, and that's nothing what is surprising. You find some clients who are public and private ones who are really understanding the situation, and some clients at the end you get the answer, yeah, okay, we understand it's better from the sustainable perspective, it's roughly the same in time, but it's not really saving money, so we don't go for it. And even some prominent projects which are writing in big letters sustainability and all the stuff, at the end it boils down very quickly to money. And on the other hand, you have real projects where it's understood, okay, if we do this in this way, it's beneficial for all parties, and at the end we will maybe even save time together because we create a proper climate. And I just see this on one very interesting big project where this was the attitude from the beginning, where from the client, consultant, some laboratories and so on, we work together, and at the end, as it turns out now, it saves significant amount of time and money, and is maybe by a factor of 5 less CO2 contribution.
Okay.
So that's exactly how it should be. But this requires the right culture and the right participants.
Yeah, and seeing it as an investment, right? Because it might cost a little bit more in the tender that you get or on paper, but investing time in people and also bringing people together, I think. So we have examples of project where new projects teams have come together to work for the first time, and projects where they've spent time together defining the project culture. How do we work together in a good way, and understanding where they're coming from, maybe different technical disciplines, but also different countries, and really taking time to get to know each other before you start working. Much more successful than where we jump into it with both feet and we basically make lots of assumptions about where other people are coming from, and even like meeting culture and stuff. And it can be massive clashes in communication and understanding of timelines. And that's really like destructive for a project. And that means it will cost a lot of money. So I think investment in people and investment in working together early on is going to give you savings in the long run.
Any comments to that, or?
No, it's obvious that you have to understand the culture you're working in the minor stuff. And it's there is a saying, you meet always again, which is a typical saying I'm used to in the Central European part, but you're unfortunately very often not any more able to follow it because there are legal or contractual or fighting conditions sometimes on sites and projects. Not always, but sometimes, or regularly, I would say, some in reality, which is here the other way around. The basic thinking is, let's see how we can work together, because that's the idea. That's the goal. And you don't go directly for a fight.
Yeah.
And I think that's a real different in mindset, and which comes very close how it should be. It's much more fun. And as Thurner said, it's beneficial, especially for the client, the time and the climate.
Yeah. And I mean, for sure, it's very understandable that, especially for young people, if you would face an environment that is infused with fighting all the time, then this is not attractive to go for anyways. So for sure, we shouldn't do that.
And we see it. Think about the lack of students in the universities. I just have numbers now from Luleå, NTNU, Graz, and other universities. We have a real lack of young people who are interested in our business. Simple as this.
It goes for civil engineering in general, I think. But I think we do have a responsibility to showcase some of the happy stories as well, because typically what you read about in the papers is everything that's gone wrong.
Yeah.
And that doesn't paint a very pretty picture of the construction industry and all the fantastic things that you can be part of. So we all kind of see the built environment around us, but most people don't think that much about it. When things work, you don't ask any questions, and then you read in the papers about lawsuits and things costing too much and fighting. That's not really something you want to be part of. So I think it's our responsibility as well to really show the positive sides of our industry. And maybe even more of a challenge for us in geotechnical engineering, because you can't even see, we all like a fantastic bridge, and to be able to say I was part of building that. But a lot of the geotechnics we do when they work are completely invisible.
For sure, absolutely, yeah. Maybe just since we speak about culture and fighting and so on and so forth, how is it in the north when we talk about claims and the contractor's client interaction? Is this as it is in other parts of Europe, where claiming is a natural part of the construction business, or is it a different way of working and coexisting here?
It's different. I think it's less intensive in the average value or average level from the industry. But there are for sure real lawsuits for different reasons, either technical reasons or projects sort of was laid up in the wrong way or things like this, or something went wrong. But you have the same, or you have also fights. On the other hand, they are for sure less intensive. And what I think is the major difference is not if it comes to a real lawsuit. There it's law, full stop. It's before. You have much more chances to do a standard project, which means you have to manage your project from both sides. You have a chance to have a partner. You have a chance to have a discussion with the consultant and the designer. Hey guys, this have to be included. You know this. And then you have to act, and you are feeling much more responsibility because you know also the other side have more responsibility or is more responsibility taking. So therefore it's a more together and it needs a lot till you start to claim in a big sense or you go on code. That's the difference. It's the daily life, and it's a bit coming back. What Thurner said, it gives in the daily life much more fun, and you cannot see a lot of geotechnics, yes, but you can still see the fun in sense of when you have developed together a project and then you have executed, it's stable there, and it's the sparkling in the eyes also of the young guys, which are proud that, okay, this is now done, and I was part of it.
Yeah, I think the fun part for me is like when we help other disciplines also do the best job they can possibly do. We all want to work in fun, successful projects. And that means, looking after your client and their priorities and needs. It's looking after the other disciplines that you're working together with and being responsible for your own part of the design. And if everyone contributes to that, there's an element of like trust and transparency in how we work and how can we together make this successful. It also then distributes the responsibility, like Robert says, we're in it together and we do the best that we can do. Sometimes we always have to worry about, what hat we're wearing or what role we're taking on and what is like really our responsibility. But I think the best projects come from a great project team.
In reality, it's very often like a project at home. If you have someone coming and you make sure that he understands that he is responsible and I expect you to deliver, and there is a very clear communication what he is expecting from your side, you deal in a standard, normal, proper, fair way with each other. And the same is on a major project in reality. If you know, okay, this client now has put his weight on us because he expects this, and this is what we have agreed and promised, then you are on a different level of delivering and also lower level on claiming.
That makes a lot of sense, yeah. Okay, good. I think this is actually quite a good point to stop with. So it's about fun, and we have to collaborate more. And I think basically the whole world can kind of learn something from Scandinavia in this regard. It's a different culture and it's very also focused on the humans. And I also do think that this is the way forward and how we can also maintain our business and get new people coming in and basically keep on doing the fun and great things that we are doing. Yeah. With that, thank you for being on the NGI Technical Podcast.
Thank you.
Thanks a lot for having us. Thank you.